Okay, this is page 5, and I'm going to try and do page 5 and 6 both in this video. So, solve the system of equations algebraically. Show each step for credit. So, algebraically means without graphing them, which, you know, I can manage now and then. They are set up very nicely for substitution. If I just take this and put it here, I get x minus 5 over 2 equals x squared minus 4. And if I can solve this single variable equation, that means that the y I get from this will match the y I get from this, and I can have my solution. So ultimately, I am still looking for a point or points that is where they cross. So I will need the x's and the y's, but I'll get to that later. For right now, because it is a system of equations and it's non-linear, so I might have 0, I might have 1, or I might have 2. I can't help but think a little graphically. So now I'm just going to try and solve this quadratic equation. If I multiply the whole equation by 2, I get x minus 5 equals 2x squared minus 8. I double this whole expression and it makes the 2 go away, right? It was halved and then it was doubled. So then I'm going to try and get 0 on one side. Since my x squared is already positive over here, I'm going to keep it positive. I'm going to subtract my x and then add my 5, and I get 2x squared minus x minus 3. So now I'm going to try and box it, see if I can factor 2x squared and try and get a minus 3. I don't know how my minus x will play out, but I need it to equal negative x there. So if I have a 2x and an x, then this row will be doubled. I need a negative 1 and a 3, or a negative 3 and a 1, and I'm going to multiply one of them by 2. Don't know if it's going to be the negative, but I'm guessing because I want to result in a negative. This would be negative 2 plus 3. This would be negative 6 plus 1. That's too big. Negative 2 plus 3 gives me a positive. Ooh, maybe I should have done 2 times positive 1 minus 3. That'll give me 2 minus 3. Yes, that's better. So I want a positive 1 and a negative 3. And I want the 1 to be where it'll be doubled. So that's a 1, that's a 1, that's a 3, and the 3 will be negative, and the 1 will be positive. Let's see if that works out. So now I get 2x minus 3x. Negative 3 times positive 1 is negative 3. Yes, and that adds to negative 3. I'm happy. I like that factorization. So 0 equals x plus 1 times 2x minus 3. Now I want where each of these is 0, which means x might be negative 1. If I subtract 1, x equals negative 1. Or where this equals 0, add 3, x equals 3 over 2. So I'm going to have one solution that starts with an x of negative 1 and one solution with an x of 3 halves. Now I need to know what the y is. I'm going to plug that into the linear version because it's a little, actually it's not. I'm going to take my negative 1 and square it to get 1 minus 4 is negative 3. I might double check that negative 1 minus 5 divided by 2 is in fact negative 6 over 2 or negative 3. So I'm happy that one works. It's a good check. My x of 3 halves now I'm going to also plug in for my x, which will give me 9 fourths minus 4. 4 is 16 fourths. 9 fourths minus 16 fourths is negative 7 fourths. Kind of ugly, but, oh, not negative 7 sevenths, negative 7 fourths. I'm going to check that in my linear one. 3 halves minus 5, which is 10 halves, over 2. 3 minus 10 is negative 7 halves over 2 is negative 7 fourths. So it actually does work out. That is the y for that x. So here is my solution set. It is the 2 points where this parabola crosses that line. I showed my steps kind of messy, but it works out. Sketch the function to identify the solutions to the inequality in set notation. So this inequality, remember h of x is basically just y, right? So the inequality part comes from wanting y to be less than 0. So I want the outputs of this function to be negative. So my solutions will be the x's that make it negative. Now this is a quadratic in zeros form, so I can go ahead and find the zeros where x minus 1 equals 0, x equals 1, and where x plus 4 equals 0, x equals negative 4. And then this is a downward facing, sad face, negative, opening down parabola. Now I have no idea where my vertex is, how tall or skinny this is, but I'm going to draw it nice and flat because all I care about is the positivity or negativity of my y's. And I want my negative y's. So the negative y's happen here, right? These are all negative y's, which means this part of the axis will lead to negative y values of my function. And this part of the axis will lead to negative y values of my function. For infinity, all the way from here to infinity, I'm going to have negative y values. My h of x, my output of my function, will be less than or equal to 0, negative y's. So my solutions are the x values. They want it in set notation. So I want the set of all x's such that x is less than or equal to negative 4. I'm going to match this sign. Its energy is my energy, okay? And then, or I'm okay if x is greater than 1 or equal to. Again, its energy is my energy. That's my set. Any x's less than negative 4 or x's that are greater than 1. If I wanted that in interval notation, I would start with negative infinity, go all the way up to negative 4 and include it, square bracket. And then I would jump over here to 1 and finish out all the way at infinity. So that would be my interval notation. This is set notation. This is interval notation. The interval notation says I want the interval from here to there or here to there. The set notation says I want my x's to meet these requirements, and it will be in set brackets, set brackets. If we call them set brackets, then maybe we'll use them every time we hear the word set. Identify the locations to the solutions to the inequality. All right, so this time I don't have a function. I can't do the math, but I have the graph, so ultimately it's faster. I want my y's to be negative, less than 0. Negative. So where are my y values? The outputs of my p function will be less than 0. Here, here. All of this. This part of the function has negative y values. So I want to identify from here to here, but I'm not going to include them. Notice I used filled in dots in the previous one. I'm using hollow dots this time. That's the sort of graphical representation for go right up to it, but don't include it, right? Like holes in our rational functions. So negative 4 to 0. This time they want it in interval notation. Great. Here's my interval notation. My interval notation is literally start at negative 4, but don't include it, and stop at 0, but do include it. Always least to greatest. Lowest to highest, leftist to rightist, whatever you want, but least to greatest. That's the way we do interval notation. Now, if this was a set, it would be all x's such that x is between, but not including -4, and 1. So that would be my set notation for the same interval. This is interval. The interval from -4 to 0, this is set. The set of all x's such that x is between -4 and 1. Page 6 now has this really wordy problem. I'm not going to read it out loud. I'm going to identify the fact that it has a standard form quadratic. And then I'm going to say, what's the maximum possible? Maximum possible will be the vertex, but only if it's opening down. Is it opening down? Yes, it's opening down. So the maximum profit, now I need to know if profit is my x or my y. I'm assuming it's my y. The profit is approximated by, which means this is profit, yes. So the y is my profit. I'm looking for that, the y value of my vertex. Now, to find that, I'm gonna need to find the x value. So since P is price, this is the price axis, I might as well start with question B here. I think I need the price in order to earn the maximum profit, which will be the x coordinate. Now in vertex form, the quadratic formula holds a lot of good things. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, I like to put my 2a, oh, it's all one piece. I like to put my 2a in both places so that I can see that this could be a sum or difference of two separate fractions, right? Plus or minus that. But if my zeros are evenly spaced plus or minus this much, then this must be my vertex. This is where it all starts. My vertex form is x equals -b over 2a. Thank you, Carson. So B is this and A is this, and I don't care about C. So the maximum or the price they need to charge is going to be -1700 over 2 times -50. Okay, take out a 10. This is also a 10 and my negatives cancel, so 10, 10, 17. $17 is the price. Now to find the profit, I'm gonna have to plug that in. Now I'm not gonna do that because I don't get out my calculators very well. But I need to find f of 17. That will be my profit. When I substitute 17 in for the variable, I will find the maximum possible profit. What price should they set to break even? 0 profit. Those are the zeros of this function. Now I need the entire quadratic formula. So x equals -b plus or minus, actually I already know that it's 17, plus or minus. Now I need the square root of b squared minus 4ac, minus 4 times -50 times 4ac, 1200, that should be -1200, 4ac, and all over 2 times a. And what I believe that came to was 10 or -3, 20? No, -7. Plus 7 is 24. Either $10 or $24 will cause them to break even. Table of values and plot the function. I don't know how to pause my video, so
I'll wait.
Okay. Yeah. So domain and range and interval notation. This is a table of values for a square root function. So here we're doing a square root function, the parent of which starts like this. But there's some stuff going on that may be a little bit too messy for me to use transformations. So instead, I'm going to use a table. I'm going to try and find values that are important. The most important point in the parent function is when the thing under the radical equals 0. That is where it starts and stops. That's the difference between a positive under the radical or a negative under the radical. 0 under the radical. So I'm going to try and find the x value that makes x minus 6 over 9 equal to 0. Again, every time you have a parent function, take what's inside that operation, set it equal to 0. That's going to be an interesting point. In this case, it's our vertex and the edge of our domain and our range. So x minus 6 equals 0 times 9, or x equals 6. So when I plug 6 in, I get 0, this whole thing goes to 0, and my output is negative 8. So my function has a key point. Its starting and stopping point at positive 6, negative 8. Now the question is, does it go off up to the right, down to the right, up to the left, or down to the left? I have to kind of do a little more work on that. I know that I don't want to pick a value less than 6, because when I subtract 6, that would make it negative, and I can't do that. So it's definitely going to be going to the right. And I want to pick a value that will maybe make this equal to 1 if I can. So what value of x will work that? X minus 6 equals 9, x equals 15. So if I pick 15, when I do that, the thing under the radical is 1, the square root of 1 is that, times 3. 3 minus 8 is negative 5. So it's going to go 15, negative 5, somewhere out here, which now tells me the general shape and direction of my function. Knowing what a square root function looks like helps a ton here. And now I can do my domain and range, which was ultimately my goal. I found my vertex, and I used one more point to help me find the direction I go. My domain started at 6. It wanted it in interval notation, so I'm going to start at 6 and include it because it is the actual endpoint. It is included. And I'm going to go all the way to infinity. Now my range, I need to find the lowest and come up to the highest. Now it doesn't go down to negative infinity, so I won't start there. Instead, I'll start at negative 8. Did I plot that right? Because that is my least value it will ever be. It's only going to go up from there to infinity eventually. Slowly, but eventually. So that's how to find domain and range in interval notation. Again, the set notation here would be x such that x is greater than or equal to 6. And the range here, now this is something people have been missing. The range is y, all the y's, such that y is greater than or equal to negative 8. So make sure you're using the appropriate variable to define the appropriate thing. Range is all your y values, domain is all your x values. Transformations to plot this function. So now this one's also a radical, also a square root, an even root that only exists for positive values under the radical, which means the most important point is when under the radical is equal to 0, or when x is negative 1. So my domain is going to start at negative 1. When I put in negative 1, I get 2 minus 0, or 2. So my vertex is negative 1, 2. I gave you a little graph to help plot that. Negative 1, 2. Uh-oh, I'm not using transformations, am I? I went back and used the same strategy I used before. Let's think about transformationally. In transformation form, I actually want this 2 to be after the function because I'm used to seeing a square root of x minus h plus k. So if I move that 2, because addition is commutative, I can do that. Now, that means that a is negative 1/2, so I've got a vertical compression and a reflection. I've got a shift to the left by 1 and up by 2. So vertical compression, fine, it'll be skinnier, but that negative means instead of going up and to the right, I'm going to go left and to the right. Now, usually I would have this point, but because of the compression, I go only by half. So instead of going 1 and square root of 1, I went, over 1 and down square root of 1, I went over 1 and down square root of 1 times 1/2. So now I have to go over 4, 1, 2, 3, 4, and instead of going down 2, I'm going to go down half of that. And then I'm going to go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, And instead of going down 3, I'm going to go down half of that. So you can see that it goes down very, that's not what I meant to do. Where did that point come from? Okay. Goes down very shallow, and I have to go over 16 from my vertex to x equals 15 before I'll find 0. In any case, the domain and range are not particularly tricky. I didn't even have to think about that 1/2 that hard, although it did say to plot the function, so I kind of did. But my domain is going to start at -1. Set notation, oops. My domain is going to be all x's such that x is greater than or equal to -1, because I'm happy for it to be -1, and I'm happy for it to go all the way forever to infinity. But I don't include infinity in my set notation because it's implied that if it's greater than -1, it'll go all the way. My range is y's, and now my y's are going to be less than, right? All my y's exist only below 2, so y is going to be less than or equal to the 2 that is my maximum value, my vertical shift. So there is my domain and range. Now in interval notation, this would be -1 to infinity, but this would be -infinity. I have to start at the lowest and go all the way to the highest of 2. So this is interval, this is set. Okay, domain, range. All right, that's pages 5 and 6.